Now consider a rigid body which is rotating across this axis with a uniform angular acceleration. This time we are taking angular acceleration alpha. Okay, so the particles of the constituting body m1 at distance r1, m2 at distance r2, and so on, they are n particles of this thing. Now the point is, when the body is given an rotational acceleration, each particle will have different linear acceleration. Why so? Because they are at different positions from the axis of rotation, but they are all revolving at the same speed. That is why they are all rotating at the same speed. That is why their angular acceleration will be constant. Their angular acceleration would be same for each particle. So consider a force F acting on any one particle. The force would be given by what? Force is mass into acceleration, which is m1 into a1. I am taking general, so let's not talk about m1 and a1. Mass force on each particle would be m into a. But we know that suppose that particle is at r distance from the axis of rotation, so a can be written as r alpha, right? This would be the mass into acceleration. But if we are talking about moment of force, what is moment of force? Moment of force is basically torque, which is force into perpendicular distance from the axis of rotation. So this force would be m r alpha times r, where r is the perpendicular distance of any such particle at a distance r from the axis of rotation. So this becomes m alpha r square. Now if I have to calculate total torque on this body, so I will be calculating the individual torques acting on each such particle. So it would be m1 alpha r1 square plus m2 alpha r2 square plus so on mn alpha rn square. If I take alpha common out, I will be left with m1 r1 square plus m2 r2 square plus mn rn square. I have taken alpha common out. What is this? We know that this is moment of inertia I, so this becomes I times alpha. This is the relation between torque and moment of inertia. And if you want to write it in vector form, so it would be I alpha. This is the required relation we are looking for.